Hey everybody, it's MoNaCo behind the camera. Wanted to show you some solution chemistry and solubility stuff. So I'm working solo here today, so I don't know if this is going to be great or not. But wanted to show you the one, formation of a solution, and two, the reaction of that solution that produces what we call a precipitate. So I got here some good old solid sodium chloride, NaCl, right there. I'm going to drop my scoopula, and then I'm going to take that, and I am going to take a little bit of scoop, right there. Not a ton. I mean, I got a little bit. Don't need a lot of this stuff. There you go. That's a little bit better. Put that into the beaker, Erlenmeyer flask here. That little amount of stuff we'll call the solute, because it's minute. It's a little bit. And to that, I'm going to add a solvent. H2O, yeah. This stuff is known as a universal solvent, water, because it does a really good job at dissolving all sorts of chemical compounds, especially ionic and polar covalent compounds. So now if you see there is no actual solid left in our liquid. And to prove you that it does dissolve, I'll add a bit more. Okay, salt does a good job at dissolving. So there's plenty in there, right? I added a little bit which made it dilute. Now I added a lot of it, which makes it concentrated. And at first it seems like there's some falling to the bottom there. But the more I swirl it, the more it mixes. You can actually watch the particles disappear and dissolve. That is dissolving. Now what's also happening at the atomic level is dissociation, but we'll get into that later. What I want to do is add to my sodium chloride some silver nitrate, AgNO3. This is 0.1 molar, which as things go is kind of dilute, but concentration is a relative thing, right? So that liquid is clear as well. So I have a clear liquid, aqueous solution, clear liquid, aqueous solution. And what's going to happen when I mix these two things? I want to put it over here just so we can see for sure. Got a squirt of the stuff, and we'll see if I can do this proper. Keep an eye. You see that? See the stuff fall to the bottom? Let me try from this angle here. You can watch in an instant white solid forms. This is what we call precipitation. See, it kind of falls to the bottom there. Looks like cloudy, wispy stuff falling there. And the question is, what is that stuff? See that white cloudy? It's actually a solid, an insoluble solid that we could identify. Stir it up and mix it. It looks like it looks like a solution now, but if I let this sit overnight, it should become separated. Or if I centrifuge it, it would separate. So the question is, I added silver nitrate aqueous, that was the pipette full, to sodium chloride aqueous. What did I get? Well, it's a double replacement reaction. So the silver metal ion, positive charge, and the chlorine negative ion, chloride ion, are going to pair up and make the first product, AgCl, right there, AgCl. And the NO3 and the Na are going to pair up and make the second product, NaNO3. Now, the question is, was that stuff that I made, the white powder, AgCl or the NaO3? Well, I look at my solubility guidelines, reference table F, it's called for it, and I see that all nitrates, NO3s, are soluble. There's no exceptions ever. So even though sodium attached here, this would be aqueous, dissolved in water still. So I can put a little AQ next to it. And this AgCl, chlorines, halides are all soluble except when they're attached to a silver. So I could put a little S in parentheses there, and now I know that this stuff was my precipitate. It fell to the bottom. It was the white powder that I now have in this liquid. I also know this is now not a solution because I can't see through it. Solutions have to be transparent. You have to be able to see through them. So it's a little bit of a playing around with solutions. We had our solute, our solvent, dilute versus concentrated, soluble versus insoluble. Heck, we even had a double replacement reaction and identified which our precipitate was. So thanks for chilling and watching. See ya!